Good afternoon to all. How are you? Okay. We shall continue the P block elements. Anyhow, today our learning objectives to learn about inter-halogen compounds. Inter-halogen compounds. All of you know about that halogen. The group 17 elements are commonly called as halogen. Okay, that means fluorine, chlorine, bromine, iodine, etc. These are all what halogens. What is an inter-halogen compound? Inter-halogen. There is each halogen, that means fluorine and chlorine combination combines to form ClF, that is called halogen compounds, inter-halogen compounds. Okay, one of a fluorine atom or one of the chlorine atom combines with the bromine, or fluorine combines with the chlorine, or chlorine combines with the fluorine, or bromine ion combines with the chlorine, or iodine combines with the fluorine to form a compound called a series of compounds called as inter-halogen compounds. Clear? That is, each halogen combines with other halogen. Each halogen combines with other halogen to form a series of compounds called inter-halogen compounds. First, you should be right that which one have the atomic number is high. For example, fluorine, the atomic number of fluorine is 9. Atomic number of chlorine is 70. So, you should be right the chlorine atom first, because the chlorine atom is atomic number high when we are comparing to fluorine. Okay? So, chlorine atom you should be right first, then you write the fluorine atom. Which one have the highest atomic number? Then you write the first halogen atom. Okay? So, one of the halogen combines with other halogen to form inter-halogen compounds. We are taking the two halogen, one is A and another one is B. Here A is less electronegative than B. A is less electronegative than B. Here we are classified into 4 types. One is AB type. Which type? AB type. One is AB2, AB3 and AB3, AB5 and AB7 type. There are 4 types. What are they? AB3, AB5 and AB7 type. Clear? These are 4 types. Here AB type means we have taken as chlorine with the fluorine. That is ClF. Second type, Br with the fluorine, bromine with the fluorine, that is BrF. Iodine with the fluorine, that is IF. Bromine with the Cl, that is bromine with chlorine, we get BrCl. Then iodine with the chlorine, okay, we get ICl. And also iodine with the bromine, we get IBr. These are all what? AB type. Because A has one halogen atom and B also having another halogen atom. These are AB type. Next about AB3 type. We are taking chlorine, one chlorine atom, that is A, and 3 fluorine atom, that is B. ClF3, BrF3, IF3. Okay, these are all what? AB3 type. Next about AB5 type. We can be taken as iodine with the fluorine atom. Okay, that is one iodine atom, fluorine atom 5. That is AB5. Next Br with the fluorine atom, bromine with the fluorine atom, bromine with 5 fluorine atom, BrF5. These are all what? AB5 type. Next about AB7 type. Okay, AB7, that is we can be taken as iodine with 7 molecules of fluorine atom. One of an iodine with 7 types of fluorine atom. Okay. These are all what? AB, AB3, AB5 and AB7 atom. Okay. These are all interhalogen compounds. Here, what is the importance means? What are the properties? What are the properties of interhalogen compounds? First point, the central atom will be the larger one. The central atom will be the larger one. For example, the chlorine atom, the combination of chlorine atom with the fluorine atom. Which one is the central atom? Is chlorine atom is the central atom. Okay. So chlorine atom is the larger one. That is, central atom is will be the larger one. That's the first one. Second one, it can be formed between two halogen atoms. It can be formed between two halogen atoms, not more than two halogen atoms. Anyway, we can be prepared two halogen atoms by means of two halogen atoms. Maybe chlorine with fluorine or bromine with chlorine, like that. Any two halogen atoms we can be take. Okay, it can be formed between two halogen atoms, not more than two. The third point is fluorine cannot act as a central metal atom. Here, fluorine is the smallest one. Am I right? In the halogen, that is the 17th group. Fluorine is the very smallest atom, the first, because the atomic number is, what is the atomic number of fluorine? Fluorine is the atomic number is 9. Am I right? So, fluorine cannot be act as a central metal atom, because due to the small size. The fourth point, it can undergo auto-ionization. It can undergo auto-ionization. That means ICl2 molecules. We are taking ICl. Here, iodine with chlorine undergoes ionization to form I- plus ICl2 minus. The two are the ions we get. So one more point, it is a strong oxidizing agent. The very important point. They are strong oxidizing agent. One of the important properties is interhalogen compound. They are the strong oxidizing agent. Next about the reaction with alkali. Okay, how the reaction is going on with alkali? We can write the equation. Please all of take the note. Reaction with alkali. Reaction with alkali. Here, the interhalogen compounds we are taking BrF5. One of the compound BrF5, that is combination between bromine with fluorine reacts alkali, that is OH minus ion. One of the OH minus ion. Here we get the fluorine ion will be leaving out. Okay, that is F minus plus, and the Br again combines with this O. Br combines with the O, we get BrO3 minus ion. BrO3 minus ion. That is a bromate ion. Which ion? Bromate ion and fluorine ion. Okay, bromate ion. That is the reaction with alkali. Like that, anymore also examples are having. Here, when heated with alkali, the larger halogen atom, here bromine is the larger halogen atom, because the atomic number of bromine is 35. Here fluorine is 9. Here the larger halogen form oxyhalogen to form oxyhalogen. Okay, that is bromine combines with the oxygen to form oxyhalogen. We get fluoride ion is leaving out. Okay, this is a reaction with interhalogen compound. Next about, what are the structure of interhalogen compound? What are the structure of interhalogen? This is important question. Structure of interhalogen compound. The structure of interhalogen compound. It We have 4 different types. One is AX type. Next one is AX3 type, AX5 type, AX7 type. These are the 4 types of interhalogen compounds. Okay. Here, and very good examples for AX type is ClF. ClF. One of the chlorine atom and also one of the fluorine atom. Next one is ClF3. It's an example for one of the chlorine atom and 3 fluorine atom. Next about AX5 type is example is IF5. One iodine atom and 5 fluorine atom. Next one is IF7. One iodine atom and 7 fluorine atom. Okay. Anyhow, these are the examples of interhalogen compounds with the types AX, AX3, AX5 and AX7. Here, the structure of AX means it is a linear. What is the structure of AX type? Linear. For example, ClF. Next about the structure of AX3 means T-shaped. Bend T-shaped. Bend T-shaped. AX5 means square pyramidal. Square pyramidal. Next, IF7 means pentagonal bipyramidal. Pentagonal bipyramidal. These are the structures. The structures can be discussed later. Okay. Anyhow, the very important area. What is the hybridization of AX types? What is the hybridization of AX3 type? What is the hybridization of AX5 type? And what is the hybridization of AX7 type? All of you know about that. What is hybridization? Already I told you that. What is hybridization? That is it is nothing but one of an intermixing of an orbital. Intermixing. For example, S orbitals combines with the P orbital, we get sp hybridization. Sp. Am I right? One of the S orbitals combines with the p orbital, we get sp hybridization. One of the s orbitals combines with 3p orbitals, we get sp3 hybridization. Am I right? And also s orbitals combines with the d orbital. S orbitals combines with the d orbital, we get sp3d hybridization. Okay. S orbitals combines with the p orbital and 2d orbital, we get sp3d2 hybridization. These are the sub-hybridization. Nothing but hybridization is nothing but it's just one symbol. We can be say intermixing of an orbital. We are mixing the orbital. Intermixing. How? What is the hybridization of AX type? What is the hybridization of AX3 type? What is the hybridization of AX5 type? What is the hybridization of AX7 type? These are the areas are very important. And also how much bond pair in AX type, and also how much lone pair in AX type, how much bond pair in AX3, AX5, AX7, etc. This should be find out. For that, we should be do on hybridization. First one, the AX type AX. Here, we are taking example is ClF. Already I told you which one has the highest atomic number? Chlorine. The atomic number of chlorine is 17. Am I right? The atomic number of fluorine is 9. So you should be right. First one, chlorine. Am I right? The chlorine. Okay. Here, all of you know how to write the electronic configuration. Previously I told you that atomic number 17, the electronic configuration EC is equal to 1s2, 2s2, 2p6, 3s2, 3p5. Am I right? We are taking the valence. Okay. Before that, as per the VSEPR theory. As per this theory only we are explaining the structure of interhalogen compounds. Okay, as per VSEPR theory. What is VSEPR theory? V refers to valence. Okay, valence. S refers to shell. V refers to valence. S refers to shell. E refers to electron. P refers to pair. And R refers to repulsion. As per this, how can we explain the structure of inner halogen compound? That is valence, shell, electron pair repulsion. As per this valence, shell, electron pair repulsion, how can we explain the structure of inner halogen compound? The structure of inner halogen compound. Okay, clear? That means first we are taking the AH type molecule. For the AH type molecule, the example is Cl fluorine, chlorine, fluorine. Okay, here the atomic number of fluorine is 70. The electronic concentration, I wrote like that. Okay, so no. Here first we are writing the ground state. Ground state. Ground state. Ground state. I am taking the last valence shell. Okay, valence shell means there is a 3s orbital. Am I right? 3s. This is a 3s orbital and 3p. 3p also like that. Okay? 3p. That is 3p. 3p also classified into 3px, 3py, 3pz. Am I right? Yes or no? Here, 3s how much electron? Having 2 electrons. And 3p how much electron? Having 5 electron. 5 electron can be accommodated like that. You should be accommodated. You should be filled singly. 1, 2, 3, 4, 5. Here. This is the ground state for CLF molecule. Next one is, this is an AH type molecule. That means one of the fluorine only can be joined here. Here have vacant orbital. Am I right? That vacant orbital, the fluorine can be attached. So we should not write the excited state. For AH molecule, ground state, after that we should be write the hybridized state. Hybridized state. Okay. Here again you should be write the 3s orbital. 3s. Next 3p. 3p. Okay. That is 3px, 3py, 3pz. Am I right? 3s having how much electron? 2 electron. Then having 5 electron. 1, 2, 3, 4, 5. Okay. And the last one is here having one vacant. That vacant, the fluorine will be joined there. Okay. Here having fluorine is attached. So now what is the hybridization? What is the hybridization? That's the question. What is the hybridization? Can you say what is the hybridization? One of an s orbital combines with how much p orbital? 1, 2, 3. 3 p orbital we get. What is the hybridization? sp3 hybridization. So the AX molecule having which hybridization? sp3 hybridization. And the structure of AX molecule is linear. Why it is a linear means this is a AX type, that is AB molecule. Am I right? AB. If you are taking the 2 atoms of AB, one of an atom, one of another atom. If you are joining these two, and what is the structure of this slide? We are saying linear. Am I right? We are saying linear. So we should be also mention the bond pair and also lone pair. Bond pair. How much bond pair? Here having how much bond pair here? 1 bond pair, 2 bond pair, 3 bond pair. How much bond pair? Sorry, bond pair. We are saying 1. This is the bond pair. This is the bond pair. How much lone pair is there? 1, 2, 3. So the bond pair is 1, 1. This is the bonded atom. Am I right? Bond pair is 1. How much lone pair is there? How much lone pair? 1, 2, 3. 3 lone pair. So here having 4 pair of electrons here. Well, out of this 4, 3 lone pair and also 1 bond pair. Clear? Okay, this is about the, as per this, that is VSEPR theory. As per VSEPR theory, we should be calculate what is the structure of AX molecule and what is the hybridization of AX molecule and what is the bond pair and lone pair. Okay, next about AX3 molecule. AX3 molecule. Here, one of the very good example is ClF3. Okay, ClF3. Here, one of the chlorine atom combines with 3 fluorine atom. Clear? One of the chlorine atom combines with 3 fluorine atom. We get AX3 molecule. AX3 molecule. One of the chlorine atom combines with 3 fluorine atom. We get AX3 molecule. How can you measure, how can you calculate the hybridization and how can you find out the hybridization of AX3 molecule? How can you find out how much bond pair and how much lone pair? The next about the structure of AX3, structure of interhalogen compound AX3. Okay, here the very good example is ClF3. ClF3. I already told you that atomic number of chlorine is 17, am I right? Cl is equal to 17 and fluorine is equal to 9, atomic number. And the electronic configuration of chlorine is 1s2, 2s2, 2p6, 3s2, 3p5. Okay. Anyhow, the ground state of Cl atom, the ground state. Ground state, chlorine atom, that is 3s2, 3p5, okay? 3s orbital, 3p, 3. Here having 2 electrons, 3s having 2 electrons and 3p having 5 electrons. 1, 2, 3, 4, 5. And next one, here only one vacant, am I right? Only one fluorine atom can be attached here. Okay, so you should be rather excited state, excited. Okay, again 3s, 3p, 3b. After the 3p, you should be rather 3d. Okay, 3D, am I right? 3D. Here having 3s, 2 electron. Here, listen all of you. Here having only one vacant. Here the second one, that is 2px, 2py. From the 2py, one of an electron is jumped to another 3D level. Am I right? 3p level to 3D level. That means here 1, 2, 3. 4, the fifth electron is jumped to, excited to another one orbital here, 3D. So how much vacant is there? 1, 2, 3. 3 vacant orbital in the excited state. So here the 3 fluorine atom can be joined here. One of the fluorine atom, second fluorine atom, third fluorine atom. Okay, that is called the hybridized state. Okay. Hybrid state. This is 3s, 3p, 3d. Am I right? 1, 2, 1. Okay. There is 3. Here, a fluorine atom will be attached there. One fluorine atom. one fluorine atom, second fluorine atom, third fluorine atom. Okay, so what is the hybridization? Remember there are 3s, okay, the 3s. What is hybridization? Can you say what is hybridization? One of the s orbital combines with how much p orbital? 3 p orbital and one more d orbital. So what is hybridization? For AX3, sp3 hybridization. What is hybridization? sp3 hybridization. The shape is bend T-shaped. Okay. Okay. Structure T-shaped. Okay. That also for the NEET students. This is only explaining about the NEET student. Okay. Those who are willing to join NEET, you should be learn this one. And also, what is the structure of T-shape? That also you should be learn that one. T-shaped means this is one of the fluorine atom. Here, this is another fluorine atom. Here, this is another fluorine atom. Okay, so join here. Fluorine, okay. This is one we can be written as chlorine. Okay, chlorine like that. Okay, can be written as next here fluorine. Can you draw? This is T-shaped. Okay. Next about AX5 type. This is the shape for T-shape. Okay, T-shape. Next one is the shape. Next one is the structure of interhalogen compounds AX5 type. This is AX5 and AX7 are very important for the NEET students. Okay, AX5 and AX7. Okay, the shape of the AX5 is square pyramidal. Okay, sorry, and before that I did not explain about the bond pair and lone pair. Am I right? For the bond pair and lone pair, I did not explain about the AX3 type. There is a 3 bond pair and 3 by 2, okay, 3 by 2, that is 3 bond pair and 2 lone pair, okay, like here, okay. Next, AX5 time, here the very good example for the AX5 time means IF5, we are taking iodine. Here the atomic number of iodine atomic number is 53, alright, 53 is the iodine atomic number. Anyhow, the last ends with 5s2 4d10 5p5. This is the electronic configuration for the iodine. We are leaving the D subshell and we are taking S and P. So we get 3s 5s2 5p6. Okay, so first we are taking 5s, the ground state iodine, that is 5s comes electron, 2 electron, and 5p how much electron? 5 electron, 1 2 3 4 5. Okay, next about hybridized state, sorry, excited state. Here the excited state, 5p5, okay, not 6, 5p5, okay, 5p5. Okay, here 5 fluorine atom is there. Here having only one vacant. So we make it 5 vacant there. Here having only one vacancy, am I right? We can be attached to only one fluorine atom. Here having 5. So we need 4 more, am I right? So excited state, how can we draw the excited state? 5s, 5p, next about 5d. 5d, okay? Here 2 electrons. 5s have 2 electron, 5p having 5 electron, okay? 1, 2, 3. We need 5 vacancies. So this electron jumps to D. That is first one. This electron is also jump to next D. So how much vacancy is there? 5 vacancy. How much vacancy? 5 vacancy. Am I right? 1, 2, 3, 4, 5. Next is the hybridized state. Which is state? Hybridized. Okay. 5s, 5p, and 5d. Here having single electron 1, 2, 3, 4, 5. Clear. Next one is a hybrid state. 5 fluorine atom they are having. Here I have 5 vacancy. The hybrid state join there. One of the fluorine atom 1, 2, 3, 4, 5. So what is the hybridization? What is hybridization? Can you say? How much is substance is there? S-orbital? Very good. 1. 1 s-orbital. 1 s-orbital. How much p orbital is there? 3 p orbital. How much d? 2. So what is hybridization? sp2 d2 hybridization. Okay, sp2 d2 hybridization. Okay, here how much bond pair is there? That's very very important. This is 1 bond pair, 2 bond pair, 3 bond pair, 4 bond pair, 5 bond pair. Okay, so we get 5 bond pair. And how much lone pair is there? Only 1 lone pair. So 5 by 1. Okay. Then what is the structure of this AX5 molecule? Is already I told you that square pyramidal. What is the structure? For the NEET students, don't forget. Square pyramidal, okay, and we should be draw the structure. Square pyramidal. Hybridization, I already told you that hybridization. What is hybridization? sp3 d2. What is the type? AX5 type. Am I right? AX5 type. The structure. Square pyramidal. Okay, here first of all you should be take here the example is IF7. Okay, IF5. Am I right? IF5. First you try iodine at the center. Okay, iodine. Next fluorine atom, fluorine atom, fluorine atom, fluorine atom. Okay. 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 Fluorine. Next about fluorine. 2 lone pair. 2 lone pair. Okay. Sorry, 1 pair. One lone pair. So how much bond pair is there? 5 bond pair. 1, 2, 3, 4, 5 bond pair and 1 lone pair. 1 lone pair. Here. Clear? Have it out. This is the structure of a square pyramidal. Square pyramidal for IF5 molecule. Which molecule? IF5 molecule. Okay. Okay. For the one pair, how much bond pair is there? Bond pair is 5. 1, 2, 3, 4, 5. How much lone pair? Only 1 lone pair. That is 1. Okay. Next about last one is AX7 molecule. Okay. Shall I run? AX7 molecules, okay? That is IF7. IF7. Already I told you that IF7. The previous I told you that the structure of AX7 is pentagonal bipyramidal. Pentagonal. Okay, how can you find out the hybridization of IF7 molecule? Hybridization of IF7 molecule. Okay, and I told you that iodine, atomic number of iodine is 53. You should be write the electronic configuration EC. That is 5s2, 4d10, 5p5. This is the electronic configuration for iodine molecule. For the ground state, for iodine, that is, we are leaving the 4d, we are taking only 5, okay? 5s. How much electron is there? 2 electron. We are taking 5p, p subshell, 2px, 2py and 2pz. Okay, 2px, 2py and 2pz. Like that, 5 also 5px, 5py and 5pz. Okay, here I have 5 electron, 1, 2, 3, 4, 5. 5p, 5. And also you should put rather D also. This is a vacant 5d. Okay, next one. This is the ground state. Here having how much fluorine atom is there? 7 fluorine atom is there. Am I right? 7 fluorine atom. So here having only one vacancy. How much vacancy is there in the p subshell? Having only one vacancy. How much vacancy? Only one vacancy. So one fluorine atom have place there. What is the remaining 6 fluorine? No place. So here one of the fluorine is jumping there. Another also fluorine go to excited state. This also from the S also from the this jump from one orbital to another orbital. Okay, next one is a excited state. Okay, this is a 5s, 5p, 5d. Okay, here vacancy only one having. You should be make up 7 vacancy. Okay, so here to here only jumping. Am I right? Here to here only jumping. Am I right? And here to here jumping. So please say the electron occupation. Here having only 1 electron. Here also having 1 electron. 1 electron, 1 electron. This electrons are jumping, and this also jumping. So here, how much vacancy is there? 1, 2, 3, 4, 5, 6, 7. 7 vacancy. So 7 fluorine atom can be attached there. That is called hybridized state. Hybrid state. This is 5s, 5p, 5d. Okay, 1, 2, 3, 4, 5, 6, 7. Okay. Now 7 fluorine atom is attached there. That is 1 hybridized 1, 2, 3, 4, 5, 6, and also 7. is a so can you say what is the hybridization? What is the hybridization? Can you say hybridization? One s orbital say what is hybridization? One s orbital, one s orbital. How much p orbital is there? 3 p orbital. How much d orbital? 3 d orbital. Am I right? One s orbital, 3 p orbital, and 3 d orbital. So what is the hybridization? sp3d3 hybridization. sp3d3 hybridization. Already I told you that the structure of sp3d3 means pentagonal bipyramidal. Pentagonal bipyramidal. So for the NEET students, please understand what is the structure. That also you should be learned that one. You should be draw on the textbook itself. Okay. I told you that page number is 90. Page number 90, the first table and column, that is table 3.7. Okay, in that table 3.7. Okay, please check that it is correct or wrong. Okay, anyhow, the structure, there is only one iodine molecule is there. So try one of an iodine molecule here. Next about fluorine. Here. Fluorine. Can you try? Somewhat upward, okay? Okay? Pentagonal. Okay, this is, you should be iodine around the center, okay? Iodine around the center. And here also, one of the fluorine. Here also, one of the fluorine. Okay, next join here. This is the shape of pentagonal bipyramidal. Here, what is my question? Here, what is the question means? How much bond pair and how much lone pair? When you are seeing the previous diagram, you can clearly understand that during the hybridization, there is no lone pair. There is a 0 lone pair having 7 bond pair. Am I right? That is a bond between iodine and fluorine. 1, 2, 3, 4, 5, 6, 7. 7 bond pair. The bond pair is is 7. There is no lone pair. Lone pair is 0. There is no lone pair. This is the structure of what? Structure of pentagonal bipyramidal. And the hybridization is for the one word, very, very important for the one word. What is the hybridization of IF7 molecule is sp3d3. Okay. Next about the oxides of halogen. Okay. Next about the oxides of halogen. That also you should be learned about oxides of halogen and also oxoacids of halogen. Here, the oxides of halogen, the fluorine reacts with them. One of the fluorine atom reacts with the oxygen. We get 2 types of salt. Okay, here I have 2 types. One is F2O. One is F2O and next one is F2O2. These are the 2 types of salt. Okay, and it has only -1 oxidation state. Negative. We can be say a negative oxidation state. This is the important point about that. Here, the fluorine reacts with the oxygen to form difluoride, difluorine oxide, and also difluorine dioxide. These are the 2 types of salt, and it has also negative oxidation state. And other halogen do not react with oxygen readily. Okay, it can be prepared by indirect method. That is not a direct method. And also having, how can you calculate the oxidation state? And the previous video I told you that how can you calculate the oxidation state. If you have any doubt, please call me. Okay, I will help you. Next about oxoacids of halogen. Oxoacid. Here, one of the important point is here we are taking the chlorine. Chlorine forms 4 types of salt, 4 types of oxoacids of halogen. Okay, chlorine can form 4 types. Okay, 4 types. One is 4 types of oxoacid, namely hypochlorous acid. The formula is HOCl. HOCl. One of the oxoacid, hypochlorous acid. Second one is chlorous acid. The formula is HOClO. That is a chlorous acid. Next one is chloric acid. Okay, chloric acid, HOClO2, chloric acid. Next one is perchloric acid. It is a HOClO3. These are the 4 types of oxoacid. Okay, oxoacids of halogen. Okay, here we should be study about the one-word question. Study about the oxidizing power. How can you measure how can we find out the oxidizing power of this oxoacid of halogen? If the number of oxide is increasing, the oxidizing power is decreasing. Okay, number of oxygen is increasing, the oxidizing power is decreasing. So as the order, how can you write the order means HOX, X refers to halogen. Okay, the order you should be right HXO2, HXO3, HXO4. Okay, this is the order. Okay, and also having about the oxidation. How can you find out the oxidation? Previously I told you that just only one or few. And remember that how can you calculate the oxidation state for such an halogen group? Okay, for example, we can take HOEF. Here all of you know that one. Hydrogen is an electropositive element, am I right? So we are taking +1. Okay, plus X, and that is oxygen. We are taking, all of you know that, and that is a -2, am I right? So -2 plus fluorine is taken as X is equal to 0. So we can be written as 1 minus 2 plus X is equal to 0. So what is X? X is equal to 2 minus 1. So X is equal to +1. This is the oxidation state of what? HOF. Like that we can find out the next one. One more example I am giving. For example, chlorous acid. What is the formula for chlorous acid? Chlorous acid, ClO. Am I right? We can take another one example, HClO2 can be calculated HClO2. How can you find out? For hydrogen, I already told you, +1 plus chlorine. Chlorine we are taking halogen, we don't know that one, we are taking that X, and also oxygen. 2 oxygen is there, so 2 into -2, okay, equal to 0. So what's the answer? +1 plus X minus 4 is equal to 0. So I will write X is equal to 4 minus 1. X is equal to +3. Okay. Like that you should be find out all the oxidation state like that. If you have it out, please call me. Okay. Anyhow, our today assignment, I am giving the today assignment. Question is, what are interhalogen compounds? Okay. What are interhalogen compounds? Write in types. It's only a small question. What are interhalogen compounds? Explain its types. I think that the page number is 89. Am I right? Page number 89 is allowed. Okay. Okay. Thank you all for your time. Have a nice day.